Today, we're diving into one of the sneakiest ways malware can possibly infect a Windows machine. Seriously, we're not just talking about hiding. We're talking about malware that uses the system's own tools to become a permanent, almost invisible part of the furniture.
So just think about this for a second. What if there was malware that didn't need a weird file or a suspicious registry key to survive? What if it could just weave itself into the very fabric of Windows, surviving every reboot and looking just like normal system activity? Well, that's not some sci-fi plot. It's a very real threat, and we're going to break it down right now.
All right, so to really get this, we first have to understand the tool that attackers are abusing. And here's the kicker. It's not some obscure bug or a flaw. It's actually a core, incredibly powerful, and totally legitimate part of Windows. That tool is called Windows Management Instrumentation, or WMI. The easiest way to think about WMI is like the all-seeing, all-knowing building manager for your computer. It knows every process that's running, what hardware is plugged in, who's logged in, you name it. System admins rely on it for, well, everything, from checking system health to running scripts. It's absolutely essential, and it's built right in.
So this trusted building manager, WMI, it has a set of master keys to every room in the building. And what attackers figured out is how to forge their own master key. This gives them the power to tell the system what to do, whenever they want, all from the inside, looking like a totally legitimate employee.
So how in the world do they actually pull this off? Well, it's not some clumsy smash and grab. It's way more clever than that. It's more like a sophisticated three-part heist that sets up a permanent base of operations right inside the WMI database itself.
And yeah, in the cybersecurity world, this whole heist has an official name, a WMI Permanent Event Subscription. It's so well known, so effective, that it's got its own entry in the MITRE ATT&CK framework, which is basically the encyclopedia of known hacking tactics and techniques. This right here is the blueprint of the whole operation. First, the attacker sets up the lookout. In WMI terms, that's an __ event filter. Its only job is to watch for something specific to happen, a trigger, like, say, a user logging into their machine. Second, they plant the operative, an __ event consumer, which is the component that holds the malicious payload, the bad stuff. And finally, they create the secret handshake, which binds the first two together. So now when the lookout sees the trigger, it gives the signal and the operative does its job. Simple as that.
And this is the most important part. This entire three-part setup isn't some temporary file that's easy to find. It's saved directly into WMI's own database on the hard disk, and that means it survives every single reboot. Because it's not sitting in a startup folder or a typical registry key, most security scans will just sail right past it without a second glance. The ghost is now, quite literally, part of the machine.
You might be thinking, okay, that seems like a lot of work. So why do attackers love this trick so much? Well, from their perspective, the benefits are just massive. So massive that this has become a go-to technique for some of the most advanced hacking groups on the planet. I mean, look at the payoff. The malware is ridiculously stealthy because it's running through trusted Windows processes. It's durable, it's not going anywhere, it's also incredibly flexible. An attacker can set a trigger for almost anything, like only run this when the CEO logs in between 2 and 3 a.m. And, in the scariest cases, the malware can be fileless, meaning the malicious script itself lives inside WMI, leaving zero traces on the file system for Antivirus to find. It is the perfect crime.
There's a famous cybersecurity talk that described this technique perfectly with this one phrase: a persistent, asynchronous, fileless backdoor. And that just nails it, right? It's persistent, it's always there. It's asynchronous, it waits patiently for the right moment, and it's fileless. It can do all its damage without ever existing as a normal file.
And believe me, this isn't some academic exercise. This is happening in the real world. Extremely sophisticated state-sponsored groups, you've probably heard the names APT29 or Cozy Bear and Turla, they've been caught using this exact method in major cyber espionage campaigns. They use it because it is incredibly effective and just brutally hard to spot. Okay, so if it's so hard to find, how do you even start to hunt for these digital ghosts? Well, let's switch hats and put on our defender caps. The good news is, even a ghost leaves a trace, if you know exactly where and how to look. As a defender, you've got two main tools in your arsenal here. First up are the native WMI activity logs in Windows. If you have them turned on, Event ID 5861 is your smoking gun. It flat out tells you, Hey, a new permanent WMI subscription was just created. For even more detail, you want Sysmon, which is a free tool from Microsoft. Think of it like a high-definition security camera that records every single step of the heist as it's happening.
And this is just beautiful. Sysmon's event IDs map directly to our heist analogy. Event ID 19, that's your lookout being created. Event ID 20, that's your operative being planted. And Event ID 21, well, that's the secret handshake that links them together. If you see these 3 events pop up in your logs one after another, you've got a massive red flag. You've probably just caught an attacker in the act.
Okay, so you did it. You found the ghost. Now what? The final piece of the puzzle is knowing how to properly kick it out of the system, and then how to lock the doors and windows so it can never get back in.
The cleanup here has to be done carefully. First things first, isolate that machine from the network, pronto. Next, you'll use tools like PowerShell to find the 3 malicious objects: the filter, the consumer, and the binding. Then, and this is so important, you have to delete them in the right order. You break the handshake first, then get rid of the operative, and finally, you remove the lookout. After that's done, it's time to do a full sweep for anything else the malware may have left behind.
But of course, an ounce of prevention is worth a pound of cure. You've got to harden your defenses, turn on those WMI and Sysmon logs, and, crucially, ship them off to a central server where they can't be tampered with. Get a feel for what normal WMI subscriptions look like on your systems, so that a new, weird one sticks out like a sore thumb. And finally, use basic security hygiene. Limit who has the admin rights to create these things in the first place, and use application controls to block shady scripts before they can even run.
So we'll end with this thought. WMI is just one of many incredibly powerful tools that are already built into your computer. Tools that can be used for good, or as we've seen, for evil. And maybe the greatest trick malware ever pulled was convincing us all it needed to bring its own weapons, when all it really had to do was learn how to use ours.